Good morning, friends. Today we are going to cover Chapter 4, Serialization Versioning. So suppose we do an object serialization. We serialize it using object output stream, write object, and convert it into a byte stream. So what does JVM does is that it will call a cryptographic hash function, which is called as SHA-1 on this byte stream. And this SHA-1 actually takes care of the name of the class or the interface, if it has implemented anything, or if it is extending any parent class or another class, and also the member fields and the methods. So based on all of these properties of this class, and also some synthetic numbers generated by the compiler, it will create a unique SHA-ID. And this SHA-ID would be stored in a variable, something called as serialVersionUID. This serialVersionUID is basically a static final long field as associated in the JVM. So suppose I created a serialization function and just serialize this object to a byte stream, and say the JVM applies all this SHA-1 cryptographic hash function on this byte stream and generates a serialVersionUID. For example, because I haven't provided any myself custom one. So suppose it creates say 47L. 47L is just I'm taking for this example, but by default it creates a very long SHA-ID for this. Suppose in this scenario we have got a serialVersionUID of 47L. Now after I serialize this to a file or a memory buffer or wherever, after that I change some small things in the class. For example, I removed a field or updated a field or added a new method, for example. And now I try to deserialize this for this byte stream, from this byte stream that we have stored in a file. Now, when we try to deserialize this byte stream using object input stream dot read object, in that case, JVM does a check. It will again calculate this SHA-1 on the byte stream, and here it will find that the earlier serial version ID was say 47L before we serialize it, and now once it again creates this object and again calculates the SHA-1 of it. Now it's because we have changed the member field or we have added a new method, whatever the changes that we have done to the structure of the class, the SHA-1 would be different. It would not be same as what it was stored before because we have made the changes in the class. So in that case, say suppose the new serial version ID comes out as say not 47, but it would be say 57 or 53, whatever. But the point here is that it would be different than what it was stored or what it was done when we serialized it, because the stayed in the structure of the class. In this scenario, after doing this check, JVM will throw invalid class exception. So in order to avoid this invalid class exception, and when you write this serialization class and when you declare, when you finally decide that a class should be serialized, so in that case, it's always a best practice that you always create a private static final field, long field number as something as serialVersionUID, and just assign it any value. Like it can be 1L, 2L, whatever the long number that you want to decide. And suppose if you have made some changes in the class and then after that you deserialize it, then in this scenario, because we have already provided our own serialVersionUID, JVM will not generate a new one. It will not apply the SHA-1 code. It will just refer to the same version UID which we have already declared, and that's why it will not show any invalid class exception. But ideally, it's always a good practice that whenever you create this serialization method and serialization for byte stream, and when you change the structure of the class, it's always advisable to again serialize it with the newer version. Don't use the older version. Although you can just create this field serialVersionUID and override that exception, but it's not correct. So as we have discussed that the serialVersionUID, this is something which the system automatically generates it at runtime by applying a cryptographic hash function SHA-1 to the structure of the class. Structure of the class is important here because it includes the names of the class, the interface it implements, and most of its members, including synthetic members generated by the compiler. And if we change any of these things, then if we fail to declare a serialVersionUID, compatibility will be broken. This is a check which JVM applies if we don't provide a default serialVersionUID, resulting in an invalid class exception. So conclusion is that it's always a good practice to declare a static serialVersionUID variable in every class that implements serializable or externalizable. So guys, this was all about the theory of this chapter. In the next video, we will dive into IntelliJ and understand this concept by writing some codes and unit test cases. So see you all in the next video.